I'm very pleased to participate in this workshop, even from across the Atlantic. We are in the early stages of what is probably a revolution in the way we interact with animals through technology. And it's impossible to know where this is going or quite what the implications are for animal welfare. I think that when we think about technology and animal welfare, it's quite obvious we're talking about an enormous range of different things. We're talking about, for example, a range of new sensors for measuring behavior, detecting movement, sound, heat, the metabolism of animals. But we're also talking about the use of big data for diagnostics, for developing best practice, and also using technology for making management decisions with robots and all sorts of other things. So it's a huge field, and I'm going to have to be a bit selective in what I'm going to do. As far as chickens are concerned, I think, as we all know, they are one of the most eaten land animals in the world, and they owe this position to the fact that they're seen as a very healthy source of meat. They're accepted across cultures, and they're so efficient that they have much less environmental impact than pork or beef. So whether some other meats are on the decline, all the projections are that chicken meat is going to increase over the next few years. But the position of chicken producers, I think, is quite problematical because they face rising costs, labor shortages, more and more regulation about what they have to do and can't do. At the same time, they are expected to do more in the way of food safety, animal welfare, and to do it with less medication, less waste, less environmental impact. So it is actually an industry crying out for technology. And the uptake of technology is rather less for poultry than it is in other sectors, for example, in the dairy sector, where the focus is very much on individual animals. I think it's noticeably less in poultry. The potential benefits of technology to welfare are very striking. The 24/7 monitoring of health and welfare, which is possible, leading to early detection of health and welfare problems and intervention to prevent them happening at all. Higher health status, because if people are, if the animals are being assessed, people are they're going to, and confident that they would be given early warning of problems, they're less likely to use medication prophylactically. So it's probably going to it could lead to a lower use of medication. It enables us to design optimum conditions for animal health and comfort, and animal-centered design of environments, allowing animals to express what is important to them. And then, as I'll come on to, the use of big data and AI to uncover best and worst practice. But I think it's important to stress that technology could also threaten welfare. Basically because it will be seen as encouraging more intensification, which for many people is a red light. It's something that could lead to a backlash. For example, if people think that it's just going to lead to greater group sizes, less human contact, they could really start to worry about animal welfare. And I think it's important that we take notice of the voices that are warning that animals should not really pay the price. And although there's a lot of potential for good welfare and technology, many of those improvements are promises only. They haven't yet been demonstrated. So what I'd like to do in this talk really is to think about ways in which we can begin to ensure that technology improves rather than damages animal welfare. And I'm going to argue that really there are three things we need to concentrate on. We need to define welfare in a way that both has public support and is measurable by technology. Now, that's not easy because the meaning of welfare is quite difficult to define anyway, and it is, as we'll see, it's quite aspirational. So it's got to bring people along, and the general public, that actually the technology is improving welfare and it's defining welfare in a way that they can agree with. But at the same time, it's got to be precise enough that it could be captured by technology. So it's not an easy issue. Secondly, we need to develop technology that specifically measures welfare in the way we've defined, sensors for welfare, big data and AI that delivers welfare. And thirdly, we, I think, have got to focus on the idea of how we demonstrate the value of technology to improving animal welfare, moving it from promises to actuality, so that it delivers value to animals, to farmers who are the ones who got to implement it, and to the public, so they don't go off technology and have a backlash against what we're trying to do. So to begin with, trying to define animal welfare, and I think a reasonable starting point is where a lot of people now are. When I say a lot of people, I include not just the public, but a lot of food companies use either the 5 freedoms or the 5 domains to define animal welfare. For example, Purdue uses the 5 freedoms, McDonald's, Tyson, Waitrose tend to rely on the 5 domains. And so I think it's a reasonable starting point. They don't capture everything that everybody might mean by welfare, but they capture a great deal of it. And so I think that's quite a good starting point. But of course, they are aspirational. How do you translate the 5 freedoms and the 5 domains into algorithms that could be actually utilized by computers, and therefore actually be the technology for assessing welfare? And I think in order to distill what this is, the meaning that is encapsulated in the 5 freedoms and the 5 domains, we need to kind of bring them down to earth a bit. And I think one way of doing that is to say the essence of them is 2 things. One is both of them put a stress on animals being healthy. For example, under the 5 freedoms, the first 3, freedom from hunger and thirst, freedom from discomfort, freedom from injury, are all about health. And the second thing is that animals have what they want. And this may be a slightly odd way of putting it, but I think it's actually what is meant when people say freedom to express normal behavior. They mean the implication is the animals want to do the certain behaviors, and good welfare means that they have the ability to do those behaviors. At the same time, they're not forced to be in a situation which causes fear and distress. They're not forced to do things they don't want to be, or be in environments they don't want to be in. And similarly with the 5 domains, they're wonderfully aspirational, but they're quite vague. Good nutrition, good environment, good health. But they stress health and behavioral interactions, mental state. And again, animals are healthy. A lot of this is very much done on the animal health, and mental state, meaning the animals are in a positive mental state, meaning they have what they want, are not deprived, and they're not in a negative and affective state. They're not fearful, stressed, forced to be in an environment they don't want to be in. So I'm not suggesting this two-liner as a substitute for definitions of animal, just simply bringing them down to earth, putting them in a form that could be actually implemented by technology. So the second thing we need to do is to develop technology for actually measuring animal welfare using these 2 criteria to judge whether or not it's actually delivering. So technology for measuring animal health is the first essential for good welfare. And as I mentioned, there's still now many different applications for monitoring the health of farm animals, for diagnosing, predicting diseases and other health problems, with huge potential for future applications that we can only kind of imagine. And I'm going to take as an example something that I'm perhaps most familiar with, which is the automated assessment of broiler chicken health. And it is a fact that the welfare of broiler chickens is currently mainly post-mortem. In other words, the welfare, the key welfare indicators are things like foot pad dermatitis, hot burn percentage, low percentage mortality, and so on. And there are only sometimes audits done on living birds. Now, of course, if you only do it post-mortem, there's no chance to intervene. It's already too late. And for example, the audits that are sometimes done, for example, the gate scoring is very labor intensive, subjective, and it's a biosecurity risk if you have auditing teams going around to different farms. And even if they are done, it only gives a snapshot on the one day and in which it happens. So it's crying out really for automation. And our system, which is called Optic Flock, aims to give an objective, continuous assessment of broiler chicken welfare throughout their life, so that there's continuous assessment 24/7, allowing for interventions and hopefully prevention of welfare problems before they become serious. And it's very simple. It consists of a camera, ordinary CCTV camera, that is linked to a small computer, such as a Raspberry Pi, and it gives immediate local processing. And this makes it very secure because no images leave the farm, so people don't need to worry about images going off the farm. And it does the visual processing immediately. It delivers an algorithm, a welfare algorithm, on a welfare verdict every day. It's designed to be very inexpensive, to be either standalone or integrated with other systems. And it is a flock level tool for flock level management, because I think although the future may be individual bird care, at the moment, poultry management is done at flock level. Dairy farmers might tailor things to individual cows, but poultry farmers have to take management decisions like change of diet or change of drinker height or change of lighting at a flock level at the moment. So we've designed it as a flock level tool for flock level management. There are other systems which track individual birds, but our Optic Flock system does not track individual birds. It does an analysis of flock movement, and it's quite simple. Each video frame is divided into 8x8 pixel squares. If the chickens don't move between frames, all the white squares remain white and all the black squares remain black. If they move, you'll see that over time, some of the white squares become black and some of the black squares become black. And it's this changing pattern of light or dark over time, which is known as optical flow, that the system is picking up. So what we actually see as the first kind of output is this average level of flock movement. This is very obvious. You can see they do move a bit at night. When the lights come on, there's a sudden increase in movement. The periods of a lot of movement and a bit of rest, they then put themselves to bed before the lights go out. And there is some movement at night, but not, and you can see this really nice pattern. But we have discovered empirically that although the average level of flock movement tells you something, it's going to intuitively tells you the level of activity, we found that by far the most useful measures are measures of variation in flock movement, that measures of variation such as variance, skew, and kurtosis. And the basic finding is that flock movement patterns vary with flock health, that healthy flocks have high mean level of movement but a low kurtosis, whereas unhealthy flocks move much less. They have a lower mean and a much higher kurtosis. And we found this for a number of key welfare issues. In other words, flocks which end up with high mortality, they have a lower mean and a higher kurtosis. Flocks which end up with a higher percentage of flock burn have a lower mean, higher kurtosis. Foot pad dermatitis, similarly, lower mean, higher kurtosis. And flocks which have poor gait scores and more lameness, they have an overall lower mean and a higher kurtosis. So what is this kurtosis? Kurtosis is a measure of variation, and it measures outliers. Like, the best analogy I can draw is if you had a race of high-level women Olympic athletes. Now, that race would have a high mean level of movement, and it would have a low kurtosis, that everybody would be much the same ability. Nobody would come in vastly before everybody else, and there would be very few stragglers. So they would come in at a bunch. There'd be a winner and a loser, but there would be a quite tight bunch. If you contrast that with something like the London Marathon or the Boston Marathon, where you've got women and men and amateurs and professionals and people wearing silly suits, there will be a much greater spread. The average speed will be less, the mean will be less, but there will be a much greater spread, a much greater kurtosis. There will be stragglers. There will be the very strong ones and very weak ones. There will be more stragglers. And basically, chicken flocks are like runners in a mixed ability race. And as the key is, healthy flocks are faster and more uniform. They have this higher mean and lower kurtosis. Unhealthy flocks are slower and more variable. They have a lower mean and a higher kurtosis. And I'll just illustrate that with two examples. The early detection of Campylobacter. Campylobacter is a major problem. It gives you very nasty stomach upsets. It's a major problem for poultry producers in Europe, less so in the States, I think, because of washing of chickens. But it is a problem in Europe. It was previously thought to be zoonotic, and in other words, not to affect the chickens. But we did a study in which we had our cameras, and then we did fecal sampling at 21, 28, 25 days, 35 days old, and fecal sampling at 28 days. We worked with two different poultry producers, and as I say, we had our cameras. And what we found was that the flocks that were Campylobacter free all their lives, which is in the green, had this very striking pattern of higher mean and lower kurtosis, whereas the flocks that were infected with Campylobacter had lower mean and higher kurtosis. And one of the things which is, I think, very striking is that this difference occurred very early on, when the chickens were less than a week old. You could begin to tell which flocks would go on to develop full-blown Campylobacter shedding long before there were clinical symptoms, which don't normally appear until 21 days. So it was not only detecting it, the Campylobacter, it was actually predicting it as well. And then we got the same result with the second company, even more. And again, a second example I can show is that of high and low levels of hock burn. The green line here is the average. A flock which had 0% final hock burn was above average for flocks right from the beginning. You could tell in the first week. Another flock which had a terrible final hock burn score, 70%, was obviously bad right from the beginning. And again, very early on, you can tell the difference between what is going to happen days or weeks later. It's predicting, not just reflecting on what's going to happen. And we have a sort of output in which the farm staff can actually see day to day how things are changing. So we now have technology for flock and individual level welfare assessment. And really almost every week, there's a new paper published on yet another way of monitoring the behavior of poultry as I say, a lot of the systems do look at individual birds. They identify individual birds, track their movements, and also look at what behavior they're doing. Another technique, obviously, is to use little radio tags. We can use thermal imaging. There are so many ways now we have of assessing behavior and monitoring health. I think we can only see this as getting better and more important. But the second essential for good welfare is what animals want. And here, technology, I think, is set to make a huge help with us with a huge advances. It can help us to understand what animals want. It can help us to discover how animals express their emotions, and it can help us to design environments for what animals want. Now, how do we work out what animals want? Well, there are lots of ways. I'm just going to discuss two. One is whether they will use something. It's no good arguing that you've enriched an animal with something if they take no notice of it. So just simply, will the animals use it? You put a shelter in the middle of a big field and they cluster under the shelter. They're telling you that by using it, this is something they want. Or we can actually ask animals to work for something, to do something like press a button or push weights. I apologize for putting a cow in a chicken talk, but this is just such a lovely example. This cow is rubbing up against a mechanical brush, and it will work. Cows will work to switch on the brushes. They will push heavy weights to switch on. They will really work hard. And you can make chickens work hard by putting weights, seeing what they will push the weights for. So we have ways of understanding what animals want, but technology can do so much more because it can give us so much more kind of in the way of data to base our conclusions on. So, for example, if you ask, what do animals want? Do broilers want to perch? And what sort of perches do they want? Of course, we can do small-scale experiments in which we modify one thing at a time. But the technology provides so much more information. We can begin to look at perching at different times of day, whether the requirements are different, whether everything changes as the birds get older, whether there are differences between males and females. We may even get to individual differences. We don't have to be overwhelmed by data. I'm sure most of us have done our apprenticeship of sitting in chicken houses with little check sheets, or straining our eyes to analyze video to get a bit of data off video. That's past. We can rely on technology to give us so much more information about the things that we want. And when I say what animals want, I just stress this is shorthand for being in an environment in which the animal finds rewarding or pleasurable, what is called a positive affective state, and not being in an environment that it finds stressful, frightening, boring, or lacking in things that it needs. That is, it's not in a negative affective state. In other words, it's an animal-centered way of defining welfare. You let the animals tell you what they want, and that's different from what is often used, which is using natural behavior. Natural behavior is a kind of quite a good guideline, but not all natural behavior is something that animals will choose. I mean, obvious one is being chased and killed by a predator. And it's rather a human-centered view of welfare, and it may or may not coincide with what an animal wants. So I think what the animal wants itself is a more reliable guide to good welfare than just using what is natural. The second way in which technology helps us understand animal emotional state is by helping us to understand the language of animals, the sounds, the gestures, the emotional behaviors that they show. I'm sure you're all aware of the kind of what's called the pleasure twitter of chicks, the little sounds that they make when they have what they want, when they're warm with each other, have plenty to eat, and so on. And this is in contrast to the distress call, the call that they make when they don't have what they want, when they're alone, when they're hungry, or they're cold. So we already have indications of what the language of animals, but technology gives us so much more information, potentially can give us so much more information about what these sounds mean. These are sound spectrographs. The way to read these is this time along this axis, frequency up this axis, and the color represent the loudness of the sound. So you can display distress calls as these repeated loud sounds, which are within human hearing range. And the pleasure twitters are softer, they cover a much wider range, but it also analyzes more different kinds of sounds. And the technology promises to be, because it can distinguish chick sounds from background house noise, to actually apply this in practice, to actually use sound to detect that there's something wrong in the chicken house, to distinguish male from female chicks, even to give an estimate of chicken weight, to detect the first signs of disease. Again, so as I say, we understand a bit about chicken sounds, but technology opens up so much more. And as you're probably aware, there are even apps to interpret chicken sounds now. You can actually, there are every cluck counts. You can actually point your phone at a chicken and learn what it's doing. So technology is opening up an understanding of animal language. And yet another way, which I think is we have even not really begun to explore, is that AI could help and technology can help welfare, is by helping us with big chicken, what I call big chicken data. If you imagine a farm in which a lot of things are being measured, things like temperature and ventilation and lighting and the behavior and the sounds and then this and that. Imagine the wealth of information you could get if everything was put together, and if this was correlated with the production and welfare outputs. I mean, you could compare farms for what is best practice. You could design the best environments based on thousands of examples. You could begin to uncover the causes of problems. You could compare farms with international and national standards. For example, if you asked a question like, is gradient lighting better for welfare than uniform lighting? Uniform lighting meaning that the whole house is illuminated pretty uniformly. Gradient lighting meaning the lighting is above the feeders, giving dark areas between the feeders, and more importantly at the edge of the house, giving them a much more varied lighting environment. Instead of doing a small scale experiment, you could actually use hundreds of farms to think, what are the effects of this? So you'd have much more information. You could base your conclusions on much sounder data. I mean, or things like if you want to reducing antibiotic use, you don't have to just rely on a small scale experiment. You could use thousands of farms if that was a problem. In other words, data quantity is no longer the problem that it once was. I mean, we tend to get overwhelmed with stacks of video, whatever it is. Our problem is going to be data quality, because the weakness of AI is the quality of its data. Rubbish in, rubbish out, biased data in, biased results out. And I think one of the things that the agricultural industry is not good at is modifying the quality of data. And I think we actually have quite a lot to learn from the way human medicine is now using large data sets. And this is one example of the UK Biobank, which is a very large but very well curated data set. For example, in measuring physical activity in humans, they don't just rely on what people have observed or their questionnaires. They actually got data in which the physical activity of people is collected by the same wrist-worn activity monitor for 100,000 participants for 1 week. So you know that the data, if you want to then correlate physical activity with something else, like blood and urine samples or whatever it is, you know that you've got really good quality data to base your conclusions on. And this enables very important questions to be asked, such as the link between physical health and sleep. And in other words, I think poultry farming had a lot to learn for human medicine. There would be big obstacles such as confidentiality getting in the way of setting up such a database. But I think the potential for that and to understand the things that really matter to welfare, health and welfare is enormous and hasn't yet been tapped at all. So the conclusion so far would be that defining good welfare as animals being healthy and having what they want does the joint job of describing widely accepted ideas about welfare, such as the 5 freedoms, 5 domains, but also facilitates the development of algorithms for good welfare. It does the two things. Secondly, development of technology to assess good welfare is making rapid progress, but obviously has a long way to go. But certainly within poultry, the uptake is so far limited. And I think it's important to recognize this. And according to the McKinsey Global Farmer Insights report, which was published last November, I think it's important for us who are concerned with welfare that the priority for farmers is improving productivity. It has to be. They're the ones who are going to implement it. They're the ones who are going to bear the cost. And McKinsey argued that the reason why there's been relatively low farmers have been relatively slow in adapting to taking up technology is mainly because they don't think it is a particularly good return on investment. They're put off by high costs, and they're obviously put off if things are difficult to install or a nuisance to maintain. And they do not feel that these advances have demonstrated short-term net benefits. And I do feel that as a poultry community, it's important we address these issues, because if farmers are not going to take them up, then all the welfare design in the world is not going to be used, and so it's not actually going to benefit animals. So I do think we have to concentrate on demonstrating the benefits of technology to animal welfare, not just as promise, but actual, in terms of demonstrating that it really improves animal health and it really gives animals what they want. Because I think a lot of companies now are demanding much better evidence than they've been satisfied with in the past. And I think it also means we need to be aware of the implications to production efficiency and the financial returns that may or may not accrue to using that technology. And I think it's important to begin by stressing the win-win situations, because often there are benefits of the technology to both welfare and efficiency. Both, for example, lead to or can lead to lower mortality, which gives you less waste, more to sell, implications, the welfare is better. Lower levels of injury, which is, again, higher welfare, but it gives you a higher quality product and better research, and better results. Lower disease levels, which would tick a welfare box and also a productivity box. Lower risk of human infection, less use of medication if you do it right. So there's a lot of overlap, but I think we do need to be aware that design for good welfare does not always improve efficiency, and therefore there may be resistance to putting it in practice. And I think we need to think about perhaps ways in which we can make it more palatable and easier for the farmers to want to install. I mean, examples might be lower stocking density, expensive or inconvenient enrichments, which would cost money, and the farmers would need a reason for installing it. So I think design for welfare does need to take into account the needs of producers. If the better welfare by design is actually going to be used in practice, and therefore is going to improve the welfare of animals. So in conclusion, the potential for welfare to improve, for technology to improve welfare is enormous. And it can improve two key elements of welfare: health through continuous monitoring with early warnings, better control over environmental conditions, and big data to better understand best practice, worst practice, causes of different things. It can also help us with what animals want by providing much greater information about what animals want that we could collect, as it were, by hand, which gives us very valuable insight into animal-centered design. The second conclusion is that if this potential is going to be fulfilled, it's going to have to depend on actually demonstrating the welfare value in practice, not just in theory, but in practice, that people who actually use it do have better welfare, and also demonstrating other benefits, financial ones, environmental ones, so that improving animal welfare is seen as win-win, not as a cost. And I think the other thing is that we have barely begun to scratch the surface of how to use large data set and AI to deliver best practice and to improve welfare in that way. So my thanks to my collaborators, and thank you too for listening, and I'd be very happy to answer any questions.
Awesome. Thank you very much, Marian. We'll go into some questions now. So I have probably more than could fill up this entire time, but I'll let others have some questions. We have some internally. So, kurtosis identifies outliers, right? And I'm wondering, is there a baseline established, or is that different for every flock?
You can compare it with whatever you want to. We started by the data, that sort of traffic light graph I showed you with the red, the green, and the yellow. That was based on a UK data set of about 80 flocks. But what we've done when we've gone to other farms, we've been on a farm in the US. I didn't want to compare UK with US directly. So what we've done is make the baseline for that farm. So what the farm manager would see is this is the worst flock you've ever had. But the point about the system is you can make any baseline you wanted to. You could have a national, an international, or a farm basis, or whatever you wanted to. And I mean, that's a really important question, because obviously when we're looking at welfare, you can't say, it's a good thing if animals dust bathe, but you wouldn't want them dust bathing all the time, would you? I mean, you know, there is an issue of what is the optimum for welfare. And in terms of activity and walking around, you wouldn't want them walking around frantically all the time, but equally you wouldn't want them never walking around. So you've touched on a really, I think, rather important issue of what is the optimum. And the best way we've thought of doing it so far, as I said, is you compare it with some kind of baseline. I suppose it's no different from comparing water use with what the breeding companies say, or you can do whatever you like. But our most useful ones, I think, have been comparing with on that same farm.
Awesome. Relatedly, so with kurtosis again, I mean, I followed your work for several years, so I've thought of these questions for a while.
Yes.
Similarly, what if there's a uniformly poor flock? You know, how do you integrate that?
I think that if you have a uniformly poor flock, you won't have absolutely every chicken not walking around. And the very small number that do will stand out like sore thumbs, and they will trigger the high kurtosis. That's what it is. If everybody's walking around pretty much, then walking around well isn't unusual. So it won't stand out as a kurtosis. It's when most of the flock are bad, a flock that's in trouble is when only a very small percentage of them are actively walking around.
Okay. So have enrichments been on the farms where you've used optic flock? And this is kind of another avenue
Yes,
with
yes,
kurtosis is environment and adding environmental complexity,
yes,
could increase activity.
yes. Well, what the one thing we did was we were working on a farm in the US, and they installed in for some of the flocks, they installed this gradient lighting. And it was very striking that with the gradient lighting, the activities were much, much more. And they were just moving around much more. And that is, I think, that was really quite interesting.
Good. So hopefully a good baseline.
I hope so. Yes. Although, of course, people worry that activity is going to reduce your FCR, so you have to be on your
Yep.
guard.
That's our selling point with broilers and welfare, right? Didn't decrease FCR. So we have a question from the audience here. Can you mention any PLF technology used in poultry farming and welfare which can be used for developing resilience traits in poultry breeding? Have you used this with breeders at all?
We are currently conducting a trial with Cobb, looking at different breeds. So if a breeding company claims that they've got a new strain with better welfare, they're going to need to know whether that's true, not just in their rather precious pedigree facility, but how it actually works when they're out there on real farms. So what we're trying to do is help them to evaluate new breeds as they, as they develop them. So I'm hoping that would be a really rather important use of this system, to give them feedback on whether what they claim is better welfare actually does come back, and then they can use that to decide which breeders to use in future.
How cool would that be if there could be like a heritability component
Oh
with
well, yes,
dog?
yes, yes, yes.
Very cool. Let's see. So we have a question about the apps. Do you know if, what was it, Cluckify? I wonder if
Yes.
Spotify's sued on that or all, but do you know if they actually appropriately recognize the chicken sounds?
No, I was just sent the link, and I thought it was quite funny to put it in. I haven't actually tried it. I haven't actually tried it, no.
Thank you. So in your opinion and your experience, your dearth of experience, what do you believe or what do you perceive as the biggest barrier to the uptake of technology by poultry companies?
It appears to be cost. That's according to McKinsey and my discussions with poultry producers. It is that they're not huge. They're not operating on very big margins anyway. They can't afford to do things that are going to cost a lot. They want evidence, demonstration that they are going to get something out of it. Now, as I say, the easiest way to do that is to show them that the technology is going to improve health, or it's going to reduce mortality, or it's going to decrease their FCR, something like that. But it seems I keep asking this question, which is, okay, well, fine, you can show that, but what about all these other things that people want to do, which may cost? What are we going to do about this? How do you persuade people to do something that's going to cost them money? And I don't think anybody has a really good answer to this question yet. I think that the extra that because somebody's got to pay. If this costs, somebody's got to pay, and there's a limit to the extent to which consumers are willing to pay. Some of them may pay a bit extra, but there's a limit on that. And I think it's something that we need to, one really does need to think about. And maybe we as academics need to think about ways and think about it the other way. In other words, thinking about welfare improvements that are feasible and if we, ideally we'd like X, but maybe if we modified it so it was not quite so good, but it would, in other words, we need to be thinking about the needs of producers as well if we want things to be taken up.
The practicality, yes, because of course
Yeah,
they're the end users, right?
exactly. They're the end users. They're the ones who pay. They're the ones who are going to have to put it in, clean it,
Yeah,
whatever.
they pay in all the ways.
All the other things that are going to happen, they're the ones who are going to bear the brunt of it. They've got to see something in it for themselves. And maybe one of the things that academics can do is to begin to think more about what they want as well as what the animals want.
Totally agree. Well, that is our time. Thank you so much, Dr. Dawkins, for